Welcome back to Quadratics and talk about them in a little more detail. For the quadratics, you're going to see it in either standard form or vertex form. In standard form, it's going to be expanded, and we're going to have ax squared plus bx plus c. And for that, we're going to use the quadratic formula. You can also use complete the square, but generally speaking, that's going to take you longer. So yeah, you just plug in your a, b, and c values, and this is actually solving for your x for the roots. Then the x coordinate for the vertex is just negative b over 2a, because the plus or minus portion is actually moving it left or right to the root. And you just plug that back in for x to find your y. If you're given vertex form, it's going to be very similar to our transformation form. I understand that there's an x when we're doing transformations, but generally speaking, people tend to avoid the k. So you will most likely see it like this. And either way, we're going to see our vertex coordinate right away. It's going to be CD, because the C is our horizontal shift and our D is our vertical shift. To find the roots, then, we just set the function equal to 0, and we solve for x. And that will give us our roots. So to look at an example of this, we'll just create one real quick. F of x equals 2x squared plus 4x plus 1. And our quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And then this form right here, it's in our standard form, ax squared plus bx plus c. So we can just plug these values in to this, and we should get our roots. So negative 4, because the b is negative for our first term, plus or minus the square root of b squared, which is going to be 16, minus 4 times a, which is 2, times c, which is 1, all over 2a, a being 2, so 2 times 2 is 4. I can simplify this down now. We've got negative 4 plus or minus the square root of 16 minus 4 times 2 times 1 is 8, so that's going to be 16 minus 8 is 8, all over 4. Now we can't pull out everything, 8 doesn't square out, but we can pull out as much as we can. When we do square roots, we need to pull out in pairs, so 8 can be broken down into 2 times 2 times 2, so we can pull out a pair of 2's. So let's do that. So we get negative 4 plus or minus 2 root 2 over 4. Now, depending on what you want to do here, or how they're asking you to do the question, you can simplify further. For me, I would break it apart. So put negative 4 over 4 plus or minus 2 root 2 over 4. That's what we're going to do. So negative 4 over 4 would just be negative 1. Plus or minus 2 over 4 is going to be 1/2. So we just get root 2 over 2. And that would be our roots. For the vertex then, the x coordinate is negative b over 2a, which in our case is going to be negative 4 over 2 times a being 2 is going to be 4, and that's going to be negative 1. So our first coordinate, our x coordinate, is going to be negative 1. We can plug that back into our function, and we will receive our y value. So y equals 2 times negative 1 squared plus 4 times negative 1 plus 1. That will be negative 1 squared is 1, so that'll be 2. 4 times negative 1 is negative 4 plus 1. And that's going to end up being negative 1. So our coordinate for our vertex, our coordinates for our vertex is negative 1, negative 1. So here's our roots. We use the quadratic formula to get there. And then here's our vertex. We use negative e over 2a, and then plug that x value back in to our function to get our y value. Next, let's take a look at the vertex form. Let's get rid of some of this up here. Okay, so let's create an example. F of x equals 2x minus 1 squared plus 2. So, if we recall, our form for vertex form is going to be a x minus c squared plus d. We can pull our vertex out right away. Our vertex is just CD. CD, which is going to be 1, 2. Next, to find our roots, we're going to set the function equal to 0 and solve for x. So let's do that. 0 equals 2x minus 1 squared plus 2. We're going to subtract 2 from both sides. Negative 2 equals 2 x minus 1 squared. We're going to divide by 2 now. Scroll down slightly. So that will simplify to negative 1. Those 2's will cancel. We'll get x minus 1 squared. We can now take the square root of both sides, so square root of negative 1, and we have to do plus minus, equals x minus 1. Add 1 to both sides to isolate x, and we're going to get 1 plus or minus, the square root of 1 is I, equals x. So there's our roots. And unless they specify that they want real roots only, you can just go ahead and give them that. That's fine. So, again, vertex, CD, and just like we're doing transformations, and then for the vertex, or sorry, for the roots, we set the function equal to 0 and isolate x. Next time we will talk about rational functions.